right, good morning, boys and girls. Lesson 2. Lesson 2 today. Who's this character? Eric. Okay, so I'll put this to the side. Biomedical engineers don't just work on knees and knee braces, right? So today what we're going to be working on is feet. So I need a volunteer. You guys need to observe, okay? This everyday happening, observe what body parts is Lily using as she walks, okay? Nothing fancy. Well done. All right, Lil, one more sample. This time we do a light jog. Anything different? So a lot of the same. McKeely?
The core.
The core, her tummy? This part?
Kind of.
Okay. Jen?
Her hip.
Her hips, nice. Addie?
Her elbows.
Yeah, I saw her moving her elbows more so in the jogging, didn't you guys? Let's see, Johnny?
When she was jogging, I saw her toes, only her front foot was on the ground.
Yeah.
Instead of her whole foot like she was when she was walking.
So we have this memo from this company. They design a specific kind of shoe for running. Read along with me. I'll read it right out loud. All right. Fast Feet Shoe Company wants to design running shoes. Before designing, we want to collect information about how people's body move when they run. Since biomedical engineers know a lot about the human body and how it works, we have hired biomedical engineer teams to help us. So that's you guys. You're one team of several. Your team is the arch height team. Okay, now we have our task. We need you to collect and analyze data about the arches of people's feet. We will gather the recommendations from all the biomedical engineer teams and combine them to make our final decision. We need to know what's an arch. Where's your arch? So this might be a little bit weird, you guys, but I'm going to ask you to take your shoe off. Left foot. Take your shoe off. If you have a sock, just take it off. Put it inside your shoe. Okay, put your hand on your heel. Sort of massage your heel. The last thing I'm wanting you to find, and it's called the arch, A-R-C-H. The arch is the part of your foot that curves up. So find it. It's right on the outside, right? Yeah, that curves up. So that's the arch. And this is what we were asked to do some data collecting on that specific part, the arch. Okay, Johnny?
So my tennis shoes, when I play tennis, I run so much that and since I don't have much of an arch on my foot, my feet hurt after I play.
This is so interesting. So this is exactly what this company, the Fast Shoe, they want to hear that about your foot. And how can they design a shoe that's going to fit for your foot? Let's start off though. What's similar? What do we all have? Let's do this rapid fire. Go ahead.
On each foot you have 5 toes.
Toes and toenails, right? Okay, Lily.
A heel.
Yeah, a heel. Go ahead.
Bones.
Yeah, we all have a lot of toe bones and feet bones. Good. Last one goes to McKeely.
The foot pad.
Yeah, the foot pad, that midsole, that midsection, the foot pad. All right, and then do you think all feet are alike? No. How might our feet be different from one another right here? Addie?
Maybe someone's arch is higher than the other.
Right, like Johnny just shared with that. So somebody's arch could be higher, somebody's arch could be flatter, lower. Awesome. Malcolm?
Somebody's foot could be bigger than the other.
Absolutely. Bigger what way? Bigger what way?
Longer.
Longer. Could it be bigger in another way?
Yeah.
What?
It could be fatter.
Wider, right? Length, width. Absolutely. So our feet are our own. What we want to collect is the arch height of everybody's feet. So this is a very sophisticated test, and it's called the wet foot test. Okay, remember, left foot. let's count. 1, 2, 3, 4, 5, 6, 7. Just gonna step right down. Ooh, gorgeous foot. So see how it's wet? So it is sort of time sensitive because we know that it's going to dry. So then Miss O can trace her own foot just like you can trace your own foot. When we begin taping all of our arches up, I'm really curious to see like where does my foot fall? High, medium, low. And I hope that you're curious about that as well. So we're here, but mostly you guys need to run this yourselves, okay?
Why is stretchers? Why stretchers? Oh my gosh, do not know Finally! Alright, now you can go over it. You're designing drawings.
What I learned is that if the arch is going to start somewhere about here, this is your midsole. So if we just draw this, this is that padding, okay? It's going to start there and it's going to end somewhere about here. This distance, this is the arch. So this C, okay? So now I'm wanting you to meet up with a clustering of 4 kids, okay? And put them in order from low to high.
Jennifer is because she doesn't really know. Let's look at ours. Mine's perfect. Yours is the same. It looks like Evan pink. Evan pink. Yeah. Pink t-shirt. She basically doesn't have a funny. I feel like we're the same.
All right, hey you guys, let's gather around. And let's start with team 1, okay? Let's get your 4 feet right up here. Now this is where we're going to be analyzing the data. What about this foot here, this arch?
Maybe like second.
We'll switch these, okay? All right. Of course, we're going to get some more data. All right. What do you guys think about that move?
Yeah.
Okay. All right, all right. Table 6. What do you think, honey?
I think I should go.
Okay, go ahead and place it right there. All right, take a minute now. This is the time, you guys. Lean in. Eli.
I think that this one should go down high.
High. High over here. Let's do a comparison. I'm not seeing that high there. What do you guys think? Turn it. Compromise to the medium? All right. This is real life data analysis. This is what these biomedical engineers would be analyzing. Now we got to go back. Originally, we were asked to give information back to the Fast Feet Shoe Company. You want to be thinking about and using these words like arches. How many different categories did we come up with?
4.
Like, what do you think?
No, actually,
1, 2, is this 3? Is that 4? Is that a 4th category?
3.5.
We can write back a letter from our class. We'll get input in from many of you, and we can just have a letter and we can mail it off. And we'll mail it to the Museum of Science. Nice job. Give yourself a round of applause. I really thought that lesson was a really strong lesson. You know, I thought, at first as a teacher, as I was sort of familiarizing myself with the unit, what does this have to do with this? But I really understand and appreciate the thought behind it, that biomedical engineers do not just design knee braces for an injured kiddo. And so it's just, you know, stepping out of this story and here's another problem and how to collect the data and do some analysis. The engagement of the children, because it was hands-on and participatory, it was really successful for them.